Hello guys, welcome to Stats with Warnke. I'm excited to tackle the challenge of AP Stats with you. Today we'll be covering calculating normal distribution calculations. Here are the learning targets that we're going to talk about today. So we're going to find the proportion of z values in a specified interval. So we're going to calculate z-scores and then use that information to get more information from our normal distributions. We're going to find the proportion of values in a specified interval, and we're also going to learn kind of the formula sheets and the technology behind everything that goes into that. So let's start off with doing the definition of our standard normal distribution. So we have our category of density curves called normal distributions that have that unimodal symmetric shape, and then inside of that, we have another subclassification, and that is the standard normal distribution. The standard normal distribution has a mean of 0 and a standard deviation of 1. So we can use that normal distribution shorthand. So we have the capital N and then the mu and sigma with our mean and standard deviation. And then we can abbreviate that as N 0, 1. So that's going to be our normal distribution with a mean of 0 and a standard deviation of 1. We're going to use that as our basis for calculating our intervals and calculating our proportions, because that's what's provided for you on the formula sheet of the APA exam. They have two tables, one with the negative z-scores, one with the positive z-scores, and it is a standard normal distribution. So whenever we're working on one of these problems, the first thing we need to do is kind of figure out what are we trying to do. So we're going to draw a normal curve, and then we're going to label that. So we're going to include the shaded in area on inside the curve. We're going to include the mean and standard deviation and any boundaries that we are interested in. Step number 2 is to do our calculations. As we do that, make sure to show work. As simple as it might be, show that arithmetic. There's a couple different ways you can do that. Number 1 is by calculating z-scores, and that's the way I'm going to show you guys and demonstrate. There's a second way that I'm not really going to cover. It's not just the calculator commands. If you write down just the calculator commands, that will not get you credit. But that is a way we'll talk about at the end of April and beginning of May. And then step number 3 is to just answer the question that was asked. So let's take a look at some examples. So here is our first one. Suppose we want to find the proportion of observations from a normal standard distribution that are less than 0.81. So we're talking about a z-score, because we're talking about our standard normal distribution, of 0.81. So we can use our formula sheet to help answer that question. So here is our AP formula sheet. If you scroll up to the top, you can see that normal distribution, standard normal distribution curve, and it has a little z on it. That tells you in the right location. There's a couple different ones, but this is the one we want. So then we find on our table that z-score of 0.81. So here is that tenths place, and then we want to find the hundredths place by using that vertical column. So right here you can see that 0.01. So that 0.81 is where the row and column intersect. So we get 0.7910. And that's what it looks like. We have the probability of getting that specific z-score is 0.791. As with normal density curves, we always phrase our answer with the qualifier about or approximately. So just make sure to include that on any questions that we talk about. These z-scores are all approximated values, and the values inside are the probabilities or the proportion of observations that are in that. One other thing I want to point out real quick is that when you look at this curve, it's always shaded into the left. On both of these, you start on the left and you go up to your boundary. So these are always less than. These are always starting from extreme small values up to whatever we are interested in. So as you read a problem, one of the first things you need to identify is asking me a less than or a greater than question. Sometimes they'll ask you in between a couple values, but usually it's going to be a less than or a greater than type of question. So always show your work by sketching a normal curve, by shading in the areas, by marking boundaries and mean and standard deviation, and by showing your work. By doing these simple steps, by sketching, shading in areas, marking boundaries, values, and showing calculations, you'll get full credit on all the problems. So let's take a look at a couple problems. In this first one here, we want to find the proportion of observations in a normal distribution that were more than 1.53 standard deviations. So that is talking about a z-score of 1.53. And right there, they say that we want the observations that are greater than. So first thing you need to do is think about what would that curve look like. Well, we're going to be shading in from 1.53 over to the right-hand side. So we're going to have to do a little bit of arithmetic from what we get in the table to find this value. So let's take a look at our z-score tables. So we're going to find that value of 1.5 on that right-hand column, go over till we get to that hundredths place of 3, and then that value is the proportion that we are interested in. So we're going to write down that number. So here is the sketch of our normal distribution, and then we have our mean and standard deviation labeled, the boundary of interest, and then shaded in the area that we are wanting. So hopefully you know that the area underneath the curve is 100%. So this 93 is obviously not the shaded in area. So we need to do 1 minus that, and we get 0.063. So when we write our answer, we include the words about and approximately. So about 0.063 is the proportion of observations in the normal distribution that were more than 1.53 standard deviations above the mean. We can also use our calculators to do this. So I've outlined the steps right here. You're looking for the calculation or the function normal CDF. So to do that, you hit second vars. The vars is by the arrows. And then you get a screen that looks like this. We are interested in normal CDF. So that's option number 2. You're going to select number 2 and then hit enter. Depending on your calculator operating system, it might look like this. This is the older operating system, or it might give you these prompts. It might ask you for the lower, the upper, the mean, and the standard deviation. If you don't have that, that's something that we're going to have to kind of memorize, or you can update your calculator operating system to include these. So the first thing we want to start with is our lower boundary. So we were interested in 1.53, so we type that in, and then a comma, and then it asks for an upper boundary. Well, technically we want like infinity. We want all of that. So to approximate that, we're just going to pick a big number. So in this case, we have 999. That number is sufficiently large for pretty much everything. If you're 1,000 standard deviations above the mean, you're pretty significantly above the mean. So then we have our mean is 0, and our standard deviation is 1. Anytime you have that standard normal density function, you're going to look at 0 and 1. So here is our next problem. We're going to find the areas under the standard normal curve, and it asks for the proportion of observations between two numbers. So take a moment and calculate those z-scores. So here's our next problem. It wants to find the proportion of observations that are between these two z-scores. So you're going to need to either use your tables or technology and find those proportions in the method of your choosing. So here's what that would look like if you chose to do the tables. You're going to sketch a graph. And so for each of those, we want this boundary and this boundary. So what that would look like, what you draw would be something like this. So we have that upper boundary of 1.79, that lower boundary of negative 0.58. So we want the area in between there. We can find that by looking at our tables or by using technology, but you should start with drawing a picture. To use technology, that's probably the preferred method here because it's going to be a little bit faster. You do second vars, you go to normal CDF. This time though, our lower boundary and our upper boundary are clearly defined for us. They give us that negative 0.58 is our lower boundary, so we type that in first. Next, we type in our upper boundary of 1.79, and then our mean is 0, our standard deviation is 1. So our conclusion is that about 68.2, because we get that decimal of 0.682, you could also write it as a decimal here, of observations from a standard normal distribution that are between negative 0.58 and 1.79. So let's move on to the next problem. First, though, we're going to talk about how do we undo this process. So we've been given z-scores, and then we're looking at either our tables or using the calculator, and from there, we are figuring out what is the probability or what is the proportion that meets a given criteria. But what if we're starting with a probability or starting with a proportion and then want to figure out what the z-score is? Well, we can work backwards. So we work the process the same. We draw a normal curve. We shade in what we're interested in. We have the mean and standard deviation. And then we're going to mark about where we think it might be. We're not going to label it yet, but we're going to say, like, we think it's in this area. And then what we do is we use technology, or we use our tables from the formula sheet. And then we find the proportion inside of that field. So instead of reading the rows and columns, we're going to look inside of that center field for that proportion that we're interested in. Or we can use our calculators and use the inverse norm command. That's what we're going to use frequently as well. And then the last step is answer the question. Take the original question, kind of remove the question parts of it, and then apply the number that we found. So here's a quick example. In the standard normal distribution, 20% of the observations are above what value? So take a moment, pause, and draw out this distribution. Label your mean, your standard deviation, and the values that we are interested in. When you get done, it should look something like this. So we have our area that we are interested in is 20%. But if we're going to read our tables only read from the left. So that area would be 80%. We have the mean is 0, standard deviation is 1. So the question asks for that 20%, but our table, using our tables, we find 80%. So let's take a look at our tables. You'll notice that in that upper left-hand corner, it starts at 50% or 0.5. And then as you go down, it increases, and as you move over to the right-hand side, that also increases. So we're looking for 80%. So I start going down, and so I see 79s, 79, 79.5, and 0.80. So we want to see which one is 80 closer to. Well, it'd be a little closer to this value. So we're going to use that z-score. So then we trace all the way over to the left, and we see that that is 0.8. And then we go up and see that that is 0.04. So we put those two ideas together, and we have 0.84 is that z-score of interest. And then we write that as our answer. So approximately 20% of the observations in a standard normal distribution are above z equals 0.84. So we have that word approximately. We have the context of whatever the question was asking. Basically, we just reworded that question with our answer. We can use our calculator to also get this answer. These won't always be the exact same, but they'll be in the same ballpark. So we hit second vars. Again, vars is by the arrow keys. And we, instead of option number 2, we want option number 3, inverse norm. The inverse norm command has these inputs. So it starts with the area to the left, and then it asks for the mean and the standard deviation. So we wanted the area to the left that was 80%. That's why drawing your picture is so important, that you plug in the right value here. And then we do comma, 0, because that's our mean, and 1, that's our standard deviation. And our calculator gives us 0.8416. So that's really close to the 0.84 we found in the table. Again, we use the words about and approximately frequently here because all of these are approximations. Your calculator is integrating the area under the curve to get this proportion. The tables have done the same type of thing. They just rounded it to 4 decimal places. And so we're using the closest ones we can find to match up with that. So approximately 20% of the observations in a standard normal distribution are above z equals 0.842. You only need to use the calculator method or the table method on all of these problems. You don't have to use both for any of these problems. You just need to pick one and use that. In general, people find one method that they like to use and they'll stick with that, and that's just fine. Here's another problem. So this is Rafa Nadal's average speed was 115 miles per hour in a recent tournament, and he has a standard deviation of 6. So we're going to use those variables, or those definitions, and we're going to calculate this percentage. So what percent of Nadal's serves would you expect to exceed 120 miles per hour? So that's a classic z-score question. So whenever you have a question like this, the first thing you should do is draw your curve and calculate the z-scores. You might want to do the z-score first, you might want to do the curve first. It doesn't matter which order you do those in, but do those two steps right at the beginning. It should look something like this. So we have 120 minus 115 divided by 6 gives us 0.83. So we can draw our curve, we label our mean, and then in this case, I've listed out all of the standard deviations, 1 standard deviation above, 2 standard deviations above, 3 standard deviations above, in this case, 4 standard deviations above. But you can also just label the mean and standard deviation. And then we are interested in 120, so that's going to be marked right here, 120. See, it's labeled x equals 120. And then we shade in that area under the curve. And then we look for what is that proportion. So you can use table A, but we're not interested in this, just the number that the table gives us. We want 1 minus that, because the number the table gives us is all of that stuff to the left-hand side. And in this case, we're interested in the right-hand side. So if we look at our tables, we again find on that left side we have 0.8, and we trace over till we get to that 0.03, and that's where that number comes from, 0.7967. And since we want the area to the right instead of the area to the left, we do 1 minus that, and we get 0.2033. We can also use the normal CDF command with our lower boundary being 120, our upper boundary being 1,000 or 999, whatever works for you. And we have a mean of 115 and a standard deviation of 6. That gives us an area of the same, 0.2023. So you just need to find one of these methods. You don't have to do both of these. You just need to find one method and use that. And then our answer is about 20% of Nadal's serves will exceed 120 miles per hour. For the second part of that question, it asks us what percent of Nadal's serves are between two values. So in general, I recommend the calculator method when it gives you two values. It's just a little more streamlined. You don't have quite as much arithmetic, but you should start any of these by calculating what is the z-score. So we have the z-score of 100 and the z-score of 110. You'll notice that both of these are negative, so both of these are below his mean. Both of these are a little bit below or a lot below his mean serve speed. So here's what that looks like. We have the proportion of z-scores below negative 2.5. Looking at our table, we get 0.0062. And looking at the ones below negative 0.83, we get 0.2033. So we can use those two values and then figure out what is the difference between them. So we take the larger boundary, that upper boundary, minus the lower boundary, and we get 0.1971. We can also use our calculator by setting that lower boundary to be that lower z-score, that negative 2.5, the upper boundary to be negative 0.83 with a mean of 0, a standard deviation of 1, and that is our proportion we get. About 20% of Nadal's serves are between 100 and 110 miles per hour. The last question we have for today is the heights of 3-year-old females. So we also talked about how normal curves can also approximate population characteristics. And so we have a mean of 94.5 centimeters and a standard deviation of 4. So the question is asking us, what is the third quartile of this distribution? So this is giving you the area, third quartile, and then asking you to figure out what is that value. So we should start by sketching a graph. We have the mean, we have the standard deviation, and the third quartile, remember, is 75%. So it looks something like this, where we have a mean of 94.5, a standard deviation of 4, and the area under the curve is 75%. So if you want to proceed, try this on your own, pause the video, and come back in just a second. So when you're done, move on to the next slide. So we can look inside of our table to find where is that 75%. So I'm going to pull up our tables. You can see inside we can find 0.72 and then kind of scroll over. We get 0.74, 0.7486, 0.7517. So it's going to be in between these two values. So which one is it a little closer to? It's a little closer to this value. So we go to the far left side, we see that's 0.6. We go up to the top, we see that's 0.07. So it's going to be that z-score, 0.67. So we plug that in for our z-score formula. We know what the z-score is, we know what our standard deviation is, we know what our mean is. We can plug in all of those values. What we don't know is what is that score, what is that height that gives us that z-score. So we'll multiply by 4, we'll add 94.5, and we get this value of 97.18 centimeters. You can also use your calculator, so you can plug in inverse norm by doing second bars, go to inverse norm, hit enter, and then the area is 0.75. It has a mean of 94.5 and a standard deviation of 4. That gives us the area under the curve is 97.2. So we can answer using either of these numbers would be correct. The third quartile of the distribution of 3-year-old female heights is about 97.2. Thank you for joining me today. I look forward to tackling the challenge of AP Stats with you again next time.